almost like plotting graphs and stuff like that. So a break from the regular class. The questions in 9.2.
Number 9.
Okay, it says the number of gallons of gas purchased by 16 customers at a certain gas station is given. Think of frequency distribution. So they give you a table there. They set it up for you, and they give you the class intervals, which means those are the sections that you're going to take. That data right there, that's what's called raw data, has a certain range to it. You're going to take that range and section it off into equal size chunks, and those are called class intervals. And then look at how many of the pieces of data fall into each chunk. And then you, if you want, you can plot a bar graph and all that. So the sizes go from 8 to 9.9 gallons, 10 to 11.9, and so forth. And finally, they get up to 19.9. Because there's a piece of data there that must go pretty high. This is 19.2. Yeah. Okay. So what happens is this. You actually have to go through that data, and every time you get to a number, 12.7, you put it in the right class interval, put a tally mark. So it's going to look something like this. There's the class intervals right here. Then there's the tally, and then there's what's called the frequency. Frequency simply means take that tally and make it into regular numbers. And you have 1, 2, 3, 4, 5, 6. So the class intervals are listed, you can see them. The tallies go like this. Okay, so this is, I'll just put a couple of these up here so you can see them. This goes from 8 to 9.9. This goes from 10 to 11.9, and so forth. All right, so these are the actual tallies. If you go, yes?
How do you figure out 4 tallies is that on that side?
You go through the numbers,
Okay.
and you simply take each number and put it in the appropriate class. So for example, the first one, 12.7, that lies down here in the third one. This is 12.0 to 13.9. So one of these marks represents that very first number there, 12.7. And the next one is 13.1. Actually, that's in the same class number. So that would be 2 marks in that class number. 9.8, no, that goes back up here in this one. See, so I'm just putting the end results here. After you've gone through and taken every single number and put it in the right class number. That's what it looks like at the end when you do that. You have to go through all those numbers, 16 numbers. There's no way around it. You just have to do it. And at that point, you have 4 here, 1 here, 5 here, 4 here, and 2 here. These are just the regular numbers for these, that's all. Nothing different there. And that completes the table. At this point, that's all they want. They're not asking you, well, they do have some questions there, but they're not asking you to draw a histogram for it. They're just simply saying complete the table. All right, which class interval has the most values? That would be this one, 12 to 13.9, which is 5 customers chose that. How many data values are represented in the table? Well, they tell you that at the very beginning, 16. So you know that. But you could add up these numbers, you would get 16. What percent of the customers purchased 18 to 19.9 gallons of gas? Okay, that class interval is down here. This is 18 to 19.9 gallons. You find out that 2 customers did, but they want the percentage. And the way we get to a percentage is, first of all, form a fraction, convert it into a decimal, and then convert it into a percent. So there's 3 stages. What's the fraction? Well, 2 out of, how many are there? 16 customers. The whole is 16. We're talking about 2 of them who bought that much in that class interval of gas. So 2/16. That would be called 1/8 if you wanted to reduce it, but the important thing is to get a decimal for it. So let's do that. Getting out the electrons. 0.125. Here's your decimal. To convert it into a percent, you multiply by 100, which shifts the decimal point 2 to the right. So it's going to go like this, boing, boing. So it becomes 12.5, then you put a percent sign on it. So 12.5% of the customers wanted the amount of gas in this particular class. Any others? Okay, let's go on to 9.3, the circle graphs. Any questions there? 35. Okay. The table provided gives the expenses for one semester. Oh, this might be applicable to some people. And it's got only 3 rows. This is tuition. And that's what you pay to college because they're nice people. And then books. That's surprisingly expensive.
Shocking.
This is one semester, by the way. And then, of course, there's housing. Unless you're in a dormitory, you still pay for that, too. So, here's the expenses. And there's a column for percent. And then there's a column for the number of degrees on the circle. So it's $9,000 for tuition, $600 for books for one semester. That's not at all surprising. When I was paying for my daughter's books at Sac State, it would easily be between $500 and $600 every single semester. Yeah, that's what books cost, as you well know. Okay, $2,400 for housing. Okay, now the question is, where did they get all these values? They ask you to fill in the two. This is the column they give you, the expenses. Then they ask you to get the percent, and they ask you to get the number of degrees in the pie chart. Okay, so how do we do that? Well, first of all, you have to have a sense of what the whole is. Huh? Again, when you're talking about a percent, it's basically a fraction that's been converted to a percent. So you have to go back to the original fraction. There are beasts out there. They're called V8s, right? So how do you get the amount in the whole? What are the total expenses for the semester? Now that would be the whole thing, right? Okay, so we add these up. 0, 0, and this gives you 10, and that gives you 11, 12. $12,000 is what you're spending per semester. Now, that's not around here. If you went to CSUMB, probably wouldn't be quite that high. If you went to a UC, yes, 9,000 for a semester at a UC is not unusual. Okay, so there's the whole. Now, when we want to know what percent is the tuition of the whole, we form the fraction. Very much like the pizza situation. You know, you've got 6 pieces in the whole, you're going to eat 2 pieces. What fraction are you eating of the pizza? So you form a fraction. So we put the 12,000 in the bottom, but 9,000 goes to tuition. Okay, well, of course, the zeros they all cancel out because they represent multiplication by 10. So those are common factors, so to speak. So you end up with 9/12. And if you want to, you can make that 3/4. And that's a nice one, because that's one of the decimals most people do remember. So that's 0.75. Now converting that to a percent, again, multiply by 100. Takes the 2 over to the right. 75% is tuition. Now, they want the number of degrees in the circle that 75% is going to represent. And the way you do that is you go back to the decimal, 0.75. We can't function with percent notation. It's very common but it doesn't do anything mathematically. So we have to always go back to the decimal that represents that percent. And then multiply that by the total number of degrees in an entire circle, which is 360. And that will give us the number of degrees for that particular piece of the pie that is 75%. And this is 270 degrees. That's 3/4 of a circle. So if you're thinking of doing a pie chart for this, you know, here's the center, let's say. Okay, 270 degrees goes all the way over here. So this piece of the pie is tuition. That's a big chunk. Okay, that's the way it is. And the others go the same way. You form the fraction, $600 for books, divided by $12,000. Again, the zeros go out, you got 6 over 120. No point in reducing, just put it on the calculator because you need a decimal anyway, so. 6 divided by 120, that gives you 0.05. That's what we'll use when we actually get degrees, but if you want to, you can create the percent, and that would be 5%. Now, to get the number of degrees, you take the 0.05 and multiply it by 360. That's 18 degrees. Now, 18 degrees is pretty small. Let's see what it would look like. We want it to go from here. 18 degrees is going to be roughly over to here. So that's a small wedge. It would be something like this. So this is going to be close. And finally, the last one, 2400, is done exactly the same way, and of course it's got to be the remaining piece of the pie. And that turns out to be 0.2, which would be 20%. And that 20% would be this over here. This would be housing. That turns out, by the way, to be 72 degrees. This is 18 degrees, this is 72 degrees. And this one is 270 degrees. If you add those up, you get 360. Get the whole pie. Okay, does this make sense? This is what Excel does with the push of a button. It has all these formulas built into it and knows how to. That's why you pay Microsoft. Okay. Anything else in 9.3? Okay. Now they've got a graph there, a pie chart. It represents the number of highway fatalities by age group in the U.S. And you can see what happens there. 15 to 24-year-old is the largest group. 25 to 34 and so forth. It says, what is the total? Well, number 5 says, how many more people died in the 25 to 34 than in the 35 to 44? Okay, 25 to 34. The number of people that's died in this particular range of time, they don't tell us what it is. 11,520. I've got dyslexia going here. 11,520 in that age range. And then the other one is 35 to 44. You just take your data right off the chart there. That's 10,880. So you just subtract, that's all. You're just getting your numbers from the chart. And that's it. 640. So sometimes the problems are very easy. Just get your numbers from the chart, calculate with them. Other times you have to do more work to create a chart itself. Anything else? Okay, let's go on. For today, we go to 9.4. Now, when we started the statistics chapter, I said that statistics is about organization, which is really presentation. Bar graphs, circle graphs, line graphs, and so forth. But it's also about analysis to some degree. And we're not going to do much with analysis because the formulas for statistics really require a bit of algebra. And we don't have that. So we're going to do very basic analysis of raw data. And what we're going to do is look at some expressions, some math expressions that enable us to get pretty much the center of a bunch of data. And if you remember the problem which had the inaugural ages of all the presidents, 42 presidents. All right, that's an awful lot of data. And someone might say, just tell me what the average age is for the 42 presidents. Oh, average. Okay, that has something to do with sort of a medium, some sort of center of data. But unfortunately, there are many ways to look at the center of a bunch of data. And we're going to look at 3 different ways. They're very popular. And one of them especially is going to be important for you because it's the way in which your GPAs are formed here at the school, grade point averages. So let's look at it. We're on page 554. And the very first type of data center we're going to look at is what's called mean, M-E-A-N. And that doesn't mean it's nasty, it just means it's used. And this is what I use to calculate your grade point average for the class. The mean. It's often called average. Okay. Now there's a very definite definition for this, very clear. And what it means is the mean, M, is equal to the sum of the data points divided by the number of the data points. So it's a fraction. And of course, a fraction could be written as a decimal, it could be written as a percent, and so forth and so on. But most of the time with the mean, it's just actually written as a number. Here's an example. This is a very good, well-chosen example here. It's on page 554. It says a small business employs 5 workers. Their yearly salaries are the following: $42,000, $36,000, $45,000, and $35,000, and finally $38,000. Okay, those are the 5 salaries, annual salaries for the workers in this particular business. And it says, find the mean yearly salary for the 5 employees. Very simple definition. Add up the data points, in other words, add up the 5 salaries, and then divide by the number, and then the number is obviously 5. So the mean is going to be plus, 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 divided by the number of data points, 5. That's the mean. Now, luckily, we've got it all calculated in the book. We don't have to actually do this. It turns out that this is 196,000 divided by 5, and that turns out to give you 39,200. So that's the mean for the data points. So if a person was going to put an ad in the newspaper trying to attract people to the business, maybe wanted to hire someone new, they might say, you know, our average salary is $39,200. And that would be a reasonable representation of the salaries. Some a little less, some a little more, average 39.2. Okay, so that's a fair way to do it. But now the book does something interesting. They say, oh, by the way, the owner of the business earns $218,000 each year. Now figure out the mean. Ah, that's interesting. Because what happens now is we have to go back. I'm going to move this over. 39,000 without owner. Okay. But with the owner, we have to add 218,000 there. And now we divide by 6, because that would be 6 data values, huh? Okay, now that's a whole different story. Turns out that when you do that, you're dividing 414,000 by 6, and that turns out to be $69,000. This is with owner. Now, if the owner put an ad in the newspaper saying our average salary is $69,000, of course they'd have tons of people applying. Most of them would end up suing them for misrepresentation. I mean, really, that is a bad misrepresentation of what the salaries are in the business. Don't you agree? Yeah. Okay, so what I'm pointing out here is that the mean is not good for all calculations. In particular, it's not good if one of the values, one or more, is very large or very small. Such a value, like that 218,000 out there, that's often called skewing the data, skewing. They're called skew values, S-K-E-W. In other words, they're disturbing the data. The data should be fairly close together for the mean to have any value at all.
Well, it's not only doing that, it's not within the same class. He's not a worker, he's an owner.
Yeah.
So in that sense, it would be wrong too.
Yeah, absolutely. I mean, he would get sued, there's no doubt about it.
Yeah.
Right. Then you'd have to pay attorneys, and his profit for the year would
Yeah,
go
then
down.
it's probably, yeah, then it would be down with the word.
Right, okay. All right, so we have to have some other way of estimating the center of the data under conditions like this. Now, another typical situation, for example, is real estate. I mean, let's say you have a cul-de-sac somewhere in Monterey. Maybe there are 5 houses on the cul-de-sac. Most of them around 350,000, maybe 400, something like that. But down at the end of the block, there's an estate, right? And that thing's well over $1 million. How are you going to represent the cost of the houses there? You know, if you're a real estate agent, what do? Just use a mean and calculate a ridiculous, you know, average that's skewed because of that $1 million house? Now that wouldn't be right, because that's a misrepresentation.
Well, you wouldn't use it. I'm in real estate for a number of years. You can't use it.
Right.
It has to be a certain number of feet, certain age, you know. That's why it's hard to find comps.
Right, exactly. But just using the basic data
Yes.
that way is not right.
No.
That's not
No.
that's not ethical.
What do you do, cancel out that? The house that's a higher cost or a lower cost, do you cancel it out?
Most of the time, that's what the agents will do. They'll just forget that house. And that's not quite right either. So there's other things you can do. So there's another kind of average, or another way of finding the center, and it's called a median. And the median is defined completely different. Its median is the middle value of the data. And the middle refers to arranging the data in ascending or descending order. So you have to rearrange the data to get the median. Your book just talks about ascending order. Okay, So let's redo this and arrange the data in ascending order and see what we get. All right, the lowest one is the 3635, huh? So we have 35,000. We have 36,000. We're just going up in order, that's all. And then a 38,000. And then we have a 42 and a 45. Okay, and then we have a 218,000. Okay. Now, let's first of all do this much. Let's get the median for just these 5 values and see how much it comes out to be. Now notice we have an odd number of values here. 1, 2, 3, 4, 5. When you have an odd number of things, data points, so to speak, then there is one middle value, because odds always have a central value. What is that? It's the one in the center. Here's 2 here, here's 2 here, bingo, that's the one in the center. Okay, that's the median. It's that simple. Okay, so this is what we call means. Now let's talk about a median. Okay, so this is the median without the boss. Okay, now let's talk about a median involving the boss's salary too. All right, so what we've got here is an even number of values. Well, an even number doesn't have a center. There's not going to be one of those values that is the center. So what you've got to do at that point is take the 2 values that are closest to the center and average them with the mean. Okay, so that means you take 38,000 plus 42,000 and divide by 2. Now, of course, that gives you, that gives you 60,000 divided by 2, which gives you, let's see, it's 40, and, no, that's 80,000. 80,000 divided by 2, which gives you 40,000. Okay. Now, that's not so bad. This is 40,000 with the boss. And notice, it doesn't, now this is the median. It doesn't differ that much from the median without the boss, or for that matter, the mean without the boss. It's a little bit higher. Obviously, it's going to make it some higher, but not that much. So it takes care of these things called skew values, these things that are way too big or way too small, and sort of irons it out so that you don't get terrible misrepresentation. This applies especially in grades, when teachers are grading. If they have a student who's, you know, let's say, got a lot of 70s and 80s and so forth, and on one test down to 30. Well, then rather than shoving everything into a mean, what this teacher will do is figure out a median value for those grades. And it's much more fair to the student to do that. So there are different types of averaging that go for different reasons. Now there's one more. There's a third one. It's called a mode. And the mode means the most common value. And unfortunately, it just doesn't apply too much to things. There's certain types of data that do have a lot of repeated values in them, but there's lots of data that does not. And so therefore, the mode is not all that popular. But let's look at some examples. For example, the one we just had up there, there's no repetition of any of the salaries at all. So we would say there's no mode for that set of data. But of course, they can create ones where there is a mode. On page 556, example 3. No, I'm sorry. Let's go on to 557.
Example 4.
Yeah, number 4. It says, find the mode of the student-to-teacher ratios from the previous example. All right, they give you, in example 3, they simply list different states and the student-to-teacher ratio. I hasten to point out that in California, it's the highest. It doesn't affect you at all, right? You couldn't care less about that. We care about it. We go into courts about this kind of stuff. You know, this is almost 21 students per teacher. And now, of course, this is in, you know, high school and stuff like that. And here, we have to just keep our mouths shut here. All right. So what they did to find the median is to find the middle value, which means they took all that data, the different student-to-teacher ratios, from this chart, and in the chart, they're not arranged in any particular order, except maybe alphabetical by state or something. But in order to find the median, you have to arrange them in ascending order. So they rearrange them, and there's an even number, unfortunately, so you've got to take the middle two, add them together, divide by 2, and so they found out that the median there is 15.45 for all the states that are listed. Okay, that's the median. All right, then they say, get the mode. Okay, you can take that same arrangement, the same ascending arrangement, because when you do things in ascending or descending order, any common values, any repeated values will be right next to each other. So it's easy to see, okay? And sure enough, if you look at that line right there, you see 16.1 repeated 3 times for 3 different states. All right? Therefore, that is the mode of this data. 16.1 is the most common value. Now, if a set of data has more than one value repeated the same number of times, if you have 2 values, let's say, it's called bimodal. And bimodal is right down there in example 6. And what they did there is they talked about quiz grading for the college algebra test. And the scores are out of 10 possible points. You've got quite a few there. But if they're arranged, and this is what takes time, you arrange them in ascending order. That takes forever to do that, especially with that many. And what you find out, and it's done in color, is that there are 6 7s and there are 6 9s. And they are by far the most common values. And they happen to be equal to each other. And at that point, you say this data is bimodal and the 2 modes are 7 and 9. Okay? If there are more than 2 that have the same number of repetitions, you say there's no mode. Okay, so there's mode. Mode is, let's just write down a few things about it. Requires ascending order. It's the number of repeated values that is the highest. And you could also say if 2 data points are repeated the same number of times, it's bimodal. Okay, so that's it for the mode. As I say, it's not a terribly popular way of getting a center of data. Now, we're down at 557, and we go to something called a weighted mean.
No, don't mention yet.
Take your picture. Want me to smile? No. Got it?
Not yet, not yet, not yet. One moment.
You need an iPhone, come on.
Okay.
Okay.
Things quiet, I don't know.
All right, so we're going to look at a mean again, but this is going to be called a weighted mean. Now, all this means is that when you look at your data, you have, again, several data points that are repeated. And they have an example here. We're on page 558. Example 7, donations are made to a certain charitable organization in increments of $25, $50, $75, or $100. Find the mean amount donated. They even give you a nice, bar chart and so forth for that, but that really has little to do with the problem. What you find is this. You find that the $25 category had 7 donations. The 50 had 5, the 75, 3, and the 100, 1. Okay, which means you have how many 25s coming in? 7. Well, you can keep adding 25 to 25 to 25 to calculate your mean, but why do that? Because we have this thing called multiplication. It's been around for a while, right? So 7 times 25, that would do it, right? So a weighted mean has repeated values using multiplication to calculate the numerator. And the numerator, remember, is the sum of the values. So for example, yes, you have 25 plus 25, and so forth. And you have this 7 times. So rather than do all that stuff, you simply say 7 times 25, plus 5 times 50, plus 3 times 75, plus 1 times 100. So that's your numerator. Instead of doing all the addition problems, you do some multiplication. And then you have the total number of contributions on the bottom, and that turns out to be 16 contributions. It's the sum of 7 plus 5 plus 3 plus 1. And you calculate that, and that turns out to be, in this case, 46.875. This is much better for calculators. If you wanted to punch this in, what button pushes would you use? You'd do something like this. You'd open a parentheses, because you do want them to add up that numerator before they divide by 16, okay? So you open the parentheses, and then you put in 7, multiply 25, add, and then 5, multiply 50, add, 3, multiply 75, add, 1, multiply 100, and then close parentheses. And then divided by 16 equals. There's the button pushes that work for that. That makes sure it does the numerator first. Okay, now let's see an example of how this is used to create your GPA. We're on page 563. It's in the homework section. And it says that most colleges and universities, weighted means are used to compute students' grade point averages. At one college, the grades A through F are assigned numerical values as follows. An A is a 4.0, a B is a 3.5, B plus rather, a B is a 3.0, C plus is a 2.5, and so forth. We don't do that here. We don't have pluses and minuses, okay? So what we have is A, B, C, D, and F. And A is 4, B is 3, C is 2, D is 1, F, of course, is not 0. So we're going to go down to number 50 there. Compute the GPA for the following grades and round to the nearest 100. And what you've got in this little table here for student is the following. The course that they're taking, this is the grade they got, letter grade, and finally, credit hours, number of credit hours. Okay, now, what is credit hours? Let's talk about that. Credit hours is the school's estimate of how difficult the course is, okay? So let's say you're taking this course, which is, I think, a 3-hour course, huh? And you're also taking another course, which is maybe library.
chords now.
All right, this is going to be weighted heavier in credit hours than that one is, simply because it takes more of your time to do it, and they realize that. So it's their way of saying, you know, if you get a good grade in something like mathematics, you put in more time than you did in the library course. And that's, you know, they recognize it. So that's what you've got there. We also need to be able to switch these things into numbers, so I'm going to split that column down the center. And how many courses do we have? We have 4 courses. Okay, this one up here is algebra, theater, music appreciation. Oh, there's always that. I don't know if we even give that here. I don't think we do. That was always fun, though. You know, music appreciation means you go into this lecture forum kind of thing, and they play this stereo music for you. And that's it. That doesn't have high credit hours. All right, this student got this in one particular semester: a B in algebra, a C, an A, and a D. Okay? Well, a B is worth 3 points. You have to convert the letters to numbers, or else you can't calculate them. Okay? So B is worth 3 points, a C is 2 points, A is 4, and a D is 1. Okay, now the credit hours are different. This particular school says for algebra, we'll give 4 credit hours, theater, 1, music appreciation, 3, and world history, 5. Okay, so how do we calculate things here? What they do is this, is they take the number value of your particular grade in algebra, which is a 3, multiply it by the weight of credit hours, and then they get another column which looks like this. This is a weighted grade. 3 times 4 is 12. Weighted. Okay. 2 times 1 is 2. Same thing for theater, same thing for music appreciation, 12. And this is 5. Okay. So there's the weighted grade that you got. They total this up. 24 and 2 is 26, and 5 is 31. And then they divide by the number of credit hours. And the number of credit hours is 5, and 3 is 8, and 5 is 13. So they take 31 and divide it by 13, and they do that as a decimal, of course. And that tells you 2.38 is your score, so to speak, for that semester. That's your average, 2.38. Now, where's a 2.38? Well, the 3 is a B, the 2 is a C, so that's a little bit, it's higher. It's what we've called in other schools a C+. That's what they get for your credit hours. Okay. One thing before you leave, we have 1 minute to go. You should understand something about grade point averages, especially the ones that go over, let's say, a year or 2 years, because most of you are here for a year and a half or 2 years. Each semester is weighted equally, but as you gather these semesters, then this is what happens. Your first semester here, which for a lot of you is right now, will be 100% of your GPA at the end of the semester. But after you take another semester next year, then each of these semesters will be 50% of your GPA. Meaning that changing your GPA next semester is going to be harder than it is this semester. If you take 3 semesters, then each counts 33 1/3% of your GPA. So as you go on, go further and further, each semester has less and less effect on your GPA. Well, what that means is, while you're taking the easier courses, which is now at the beginning, work harder and get a good GPA. You know? And as you go on,
We have homework? No.
yeah, you do have one.